Hello everyone. So today we'll be solving the problem number 1851, meaning minimum interval to include the each query. So here, let's see what the question states here, man. Right. So we are given intervals L comma R, nothing but the left comma right here, Li Ri, and queries basically. Right. For each query Q, so see here we are given the intervals. This is nothing but the intervals. This is start, this is end, left comma right, right. So also we have been given queries 2 3 4 5. What are these queries basically? For each query Q we have to return the size R minus L plus 1, right. So just remember this one. For each query Q, this one for the 2, so we have to go with 4 minus 1 plus 1 basically. 4 minus 1, 3, 3 plus 1 is nothing but the 4 basically. R minus L plus 1 of the smallest interval that contains Q. We have to go with the smallest interval that contains Q, or minus 1 if none, right. So we have to display minus 1 if it's none, right. So intervals and queries sizes can be up to 10 to the power of 5. They have strictly mentioned here. Just give me a second here. Yep. So intervals and the query sizes can be up to 10 to the power of 5. So we need an big of n plus q logarithmic n approach. Just remember this one, right. So let's go with the approach man here. So let's go with the first example here. Intervals we have 1 4 2 4 3 6 and 4 4. Queries we have 2 3 4 5. Let's go with the first one here. We have to sort this one, right. So let's consider the same example along with the approach so that we understand this one clearly. They have given the explanation as well. You can just go through it, so it will be easier for us to solve the problem, right. So this is similar to same thing goes with the example 2 as well. So let me directly consider this one for the approach so that we understand this one clearly, right. So here, so we'll be going with the sorting mainly, right. For the intervals based question, mostly we'll be making use of the sorting first, right. So we will sort the intervals by left. So this one is left, this one is right, right, for all the thing, for all the intervals that they have given, 1 4 2 4 3 6 4 4. The first interval is L and the second interval is R. So we'll be sorting the intervals by left, not the right. We'll be sorting the intervals by left. Sort the queries with their original indices, right. So queries become so first queries become this one. Queries is 2 0 3 1 4 2 and 5 3, right. So queries we have been given, we get here basically like this: 2 0, this one, then comes 3 1, and then comes this one 4 2, and finally it is 5 3. So I'll just go with 5 3 here, right. So this is fine, man. Yep. Now we will be making use of the pointer over intervals and the minimum heap keyed by this one, interval size. What we'll be doing for the query 2 basically, for the query 2 we will push intervals with the left that is less than or equal to 2. In simple terms, we will push 1 4 here for the query 2. So let me write here for the query 2, what we'll do, we'll push 1 4 here, right. So we'll push 1 4. Size basically, size is size equals 4, and also we'll be pushing 2 4, and size is 3 here. We'll be pushing 1 4 and 2 4. 1 4 is of the size 4 and 2 4 is of the size 3. So we have to remove none here. We don't have to remove anything here. All right greater than or equal to 2, and heap top is equivalent to the size 3. So answer of 2 will be equivalent to 3 here. So this is answer is nothing but the result variable. You can consider anything. I'll just write it over here. Answer of 2, that will be equivalent to 3. This is fine. So the next step would be we have to consider for the query 3, right. So we have considered for the query 2. Now we have to go with the query 3, query 4, query 5, right. So we have the queries 2 3 4 5. So we need to consider for the query 2, query 3, query 4, query 5. So let's go with the query 3 now. So for the query 3 we have to add the intervals with left less than or equal to 3, because we have 3, value 3, right. For the query 3 we have to push 3 6. So we have only one thing here, we have to push 3 6 here, right. So we have to push 3 6 here. So this is fine. So when we push 3 6, this is of size 4. So now also we have to remove nothing. We have to remove here nothing, because heap top still consists of the size 3. So answer of 3, answer is nothing but the result variable. Again, I'm telling you, don't have to get confused here. So this one is answer of 3, this remains 3 itself, right? So this is fine. Answer of 3 remains 3 itself, right? So this is fine. And let's move on with the query 4. So we have to go with the 4 queries they have given here. Queries, this one, what do we call, 3 3 4 2 3 4 5, right? So we have went with 2, we have went with 3, now we are left with 4 and 5. For query 4, we have to add the intervals with left less than or equal to 4, meaning, so we have only one thing, 4 comma 4 here, right? So let's consider, or let's push 4 comma 4 here. Let's push 4 comma 4, which is of size that is equivalent to 1, right? So again we have to remove none, we don't have to remove anything here, and heap top will be equivalent to the size 1. So answer of 1 here will be equivalent to 1, right? So simple. Answer of 1 here, it will be equivalent to 1. So we got 3, we got 3, we got 1 here. Finally, we are left with only one query, the last query. Queries we have been given 2, 3, 4, 5. So we went with 2, we went with 3, we went with 4 previously. Now we are going with a 5. So for the query 5, we don't have any intervals to add here. We don't have any intervals to add. So we will pop the heap entries whose right is less than 5. Whose right is less than 5. Those that end at 4 in simple terms, right? So remaining top is here 3 comma 6, 3 comma 6, which is of the type, which is of the size 4 basically. So what we will do here, directly we can consider answer of 5 is nothing but the 4 here. Answer of 5 is nothing but 4 here, right? So answer of 5 is 4. So we will we have to return answer and original query order, right? So what is the query? This one we got here 3 3 1 and 4. So we have to go with first 3 for the query 2, for the query 3 it is 3 again, for the query 4 it is 1, for the query 5 it is 4. So the output that we got here is 3314, which is equivalent to the output that they have mentioned for the example 1 within the question. Very simple, right? So basically what's the key idea here? We are just iterating the queries in the ascending order, right? So we are iterating the queries in the ascending order, then we are adding all the intervals that start less than or equal to query, and we are maintaining a minimum heap by size while removing the intervals that end before that particular query. That's what we are doing here, basically the key idea, right? So the output that we got here is 3314, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here, right? So as we are done with the approach part, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to this one because of I can just write it on this way. Let me write it on this way itself. Because of n plus q, this one logarithmic n. So we are making use of this one, right? What do you call heap, min heap basically, right? So this will be because of n plus q log n, because we are going with a sorting as well, right? Sorting plus always sorting plus a dominant factor, and it will lead to because of n log n basically, right? So sorting intervals takes because of n log n, and the sorting queries take this one because of q log q, right? So it takes because of q log q here, right? So and heap operations overall we can consider because of n plus q logarithmic n, right? So this one, the time complexity would lead to because of n plus q logarithmic n. So just remember one thing, whenever we are solving the problems based on the intervals, 99% of the times we'll be going with the sorting basically. So sorting is the main thing when it comes to this one, what do you call, intervals based question. So one more thing, if you are making use of the trees, usually we'll be going with this one, recursion. I'm not saying we cannot make use of the iteration, we can, but 99% of the time we will be going with a recursion when it comes to trees, right? So when it comes to intervals, again 99% of the times we will be going with a sorting, right? So this one will be going with a recursion. For the trees we'll be going with this one, what do we call, sorting when it comes to intervals based question. And also one more thing, when we are solving the linked list problems, 99% of the problems includes the dummy node, right? So we'll be considering the dummy node, right? So most of the times, and we will exclude that dummy node at the end while we return the solution, basically the final this one output. So it will be easier for us to solve the problem using the dummy node. So we'll be making use of the dummy node most of the times. So these 3 points we have to keep in mind, right? So when it comes to linked list, we'll be making use of the dummy node most of the times, 99% of the times. So see here, basically when we solve this one tree based problems, we'll be making use of the recursion. So also backtracking, nothing but it uses recursion as well. Backtracking is nothing but the recursion, so we'll be going with helper method, backtracking and solving usually, right? So that is also completely based on the recursion itself. So here also when we are solving the problems on this one, mainly intervals, this is the last problems on the intervals. So I am saying this, usually 99% of the problems will be going with the sorting, right? So we'll be going with the sorting, just remember this. So this will be very helpful when we are giving something interview, DS interviews, right? Data structures, interviews based on the data structures and algorithms mainly, right? So this is fine. Overall time complexity would lead to big of n plus q logarithmic n. So what will be the space complexity here? The space complexity would lead to big of n plus q, right? So the space complexity would lead to big of n plus q here, because heap, so we are making use of the heap, right? So heap may hold up to n intervals, and we store sorted queries and the output as well. So overall space complexity would lead to big of n plus q. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n plus q logarithmic n and big of n plus q respectively, right? Now as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code, right? So just give me a second here. Yep. Let's start writing the code. The first step here would be this one. What do we call? Let's go with the sorting. So as we had discussed in the approach, we have to sort the intervals by their left hand point, right? Basically in the ascending order. So I'll just give here arrays dot sort. So let me copy the intervals. I don't want to this one, what do you call, type this one every time. So this one will be is here. So this one will be intervals, new comparator. This is fine. Comparator. So this one will be int. Yep. This is fine. Why did I miss anything here? Oh, this one has to be angle brackets basically. Sorry. Yeah, now this is fine. Now let me give parenthesis here as well. So now what should I do? So let me open the flower brackets here. So I'll just go with the method here, compare. This is fine. So let me go with int a comma int b. So this one also, it has to contain the array. That's of the type. We have to mention the array here. This is fine. Now we have to compare left I, right? So based on the left, so this one has to be integer dot compare. So this one has to be a of 0 comma b of 0. This is fine, man. Let's do one thing. Let me come out of this one entirely. Now what we'll be doing, so we'll be going with the number of intervals as well as the number of queries, right? So let me assign n to intervals dot length here. This is fine. Also let me assign m to queries dot length. This is fine. So the next step would be, we have to build the array of this one, query value comma original index for the for sorting queries basically. So I can just write it on this way, and I'll query with index, right? So I'll just write here q with index. So this is fine, with index. So this will be new int of m and 2. This is fine. The next step, each entry, we have went with the each entry, nothing but the value comma original index. Next part, let's go with the iteration part. So this one will be for loop. So I'll just go with int I equals 0 I less than m, so this one will be I plus plus. So this one q with index, so this one will be I equals new int of, let me go with here, queries of I comma I. This is fine. uh, we have went with the this one, right? That brackets, correct. This is fine, man. Now what we need to do here, so we have to sort the queries by the query value in the ascending order basically. So again, so let me do one thing, let me copy the same thing and make the necessary changes over here. So this part I'm speaking of this one, right? So let me copy this one. Now we are sorting the queries, right? So this one will be, instead of this one intervals, this variable name we have to consider as we are dealing with the queries here. So this one remains same, new comparator, and this is same, public int compare. So this one int but this remains same. So here integer dot compare, so this one also will remain the same, int a of 0 comma b of 0, except that we have to go with query with the index instead of the intervals. We are sorting the queries by the query value in the ascending order, right? So this is fine. Let me come out of this one entirely. Now as per the this one, what do you call, approach, so we will be going with the result array, right? So I went with answer basically, right? So let me consider answer itself, and the approach I considered answers. So this one will be answer variable, new int of m. This is fine. Next, let's go with the default -1. We have to go with the default -1. They have set this one in the question itself. We have to go with the default -1 if no interval contains the query. So this one will be arrays dot fill answer comma -1. This is fine. Yeah. So we went with the so we have to go with the minimum heap as I've said. So we'll be making use of the priority queue for that, right? So I said we'll be going with the min heap. During the approach also we considered with the minimum heap itself, right? So we'll be going with the minimum heap or the priority queue that stores int basically, size comma rate, right? Also we'll be going with a heap ordered by the size in the ascending order. So smallest interval is on the top always, right? So that is the reason we are going with a minimum heap basically. So I'll just go with priority queue here. So this one, let me give here angle brackets, let me close this one. Within this one, let me go with int, the variable pq equals new. So let me copy this one again, let me paste it over here, priority queue. So this one will be new comparator, right? So this one will be new comparator. This is fine. So this one will be int. Yep. So again, let me do one thing. Let's go with the what do we call? So we have to sort this one, right? So again, we have to go with the public int compare. So the same thing, integer dot compare a of 0 and b of 0. This one, let me copy paste the same thing, man. So just give me a second here. So this is fine. So here I forgot to give this one more this thing, flare bracket. So this is fine, man. Fine, this is fine, this is also fine. So yep, let me come out of this one entirely. Now we need the index, so we need the pointer for the intervals array, right? So let me initialize index to 0. So let's iterate over the sorted queries. So this one will be for in qi of q with index. So this one within the for loop, let's go with the current value, current query value, and also original index of this query, right? So this one will be int qval equals q I of 0. This is fine. Also let me go with let me deal with one more thing. So we have to go with the original index of that particular query, right? So I'll just go with int q, I'll just go with qr ig. So this one I'll just go with this one. So let me assign this one to the qi of 1, right, initially. So this is fine, man. Now we have to add all the intervals whose left is less than or equal to qval into the heap or the priority queue. Basically min heap we are considering, right? Minimum priority queue. So this one, while index less than n, and so this one, let me copy the intervals. I don't want to this type this one every time. Intervals of index 0 less than or equal to qval. Then we have to go with the interval left, we have to go with the interval right, we have to compute the interval size, also we have to go with the push size comma right into the heap, and finally we have to advance to the interval pointer, right? So this one will be int left equals intervals of idx index 0, and the next part is int right equals intervals of index 1. So this is also fine. And the next one would be, we have to compute the interval size. So this one will be int size equals this one will be right minus left plus 1. This is also fine. We have to push size comma this one right into the heap, right? So I'll just go with a offer operation, and I'll just go with new int here. So this is fine. Again I have said that we'll be going with a size comma right here, right? So push of size comma right into the heap, right? So this is fine. Now what we need to do, we have to advance the interval pointer as well, meaning we have to increment this one, right? So let me do one thing. Let me increment index here. Let me come out of this one entirely. Now we are left with only certain things. We have to remove the intervals from the heap or the priority queue that end before the query value, right? So right has to be less than the query value here. So I'll just go with while not of priority queue dot is empty. So this is fine. And priority queue dot peak, this is fine. 1 less than q value, this is also fine. So we'll discard the, we have to discard the intervals that do not cover current query. So this one will be pq.poll, this is fine. Yep, let me come out of this one entirely as well. We are left with only one thing, meaning we have to go with the top of the heap if it exists, that is the smallest size intervals that contains the query value, right? So here if not of pq, I'll just make use of the is empty operation, right? So this is fine. So we have to store the size. So this one will be, we are storing in the answer variable or the result variable, answer of q orig. So that's what we have considered variable name, right? So this one will be pq priority q dot peak, and also we'll be going with a 0 here. We are storing the size here. Else what we will do, we have to, meaning no interval contains query value here, right? So this one will be answer of q original. So this one is fine. Query original, we have to set this one to the -1. So no interval, when no interval contains the query value, right? So let me come out of this one entirely. Finally we have to return the results in the original query order, meaning we just have to return this resulting variable answer, ans we have considered, right? So this is fine. So this is it for the code, simple one, right? So only sorting man. See here, sorting, this contains sorting, this one priority queue, again sorting. So 3 times we have sorted, and also we have considered the priority queue, right? So that's the main thing, sorting, overall sorting, and you have to know how to make use of the priority queue. That's it. So answer may be a little bit lengthier. We have went with the sorting thrice here, and also we have made use of the priority queue. This is not something that's not solvable. It's just the code is a little bit lengthy. That's it, right? So let me run this one. Hope this is correct, man. Yeah, the sample test cases are getting passed here. So let me hit the submit button. So I hope this works for all the test cases. Let's see. So here all the test cases are getting passed, means the code works absolutely correct here. The code works absolutely correct here, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.